So we're talking water today. Whether it's negative or positively charged, it doesn't matter. What matters is that it has a charge. It is charged. If it's charged, it's polar. So polarity means it has a charge. And then as you kind of go down the spectrum from polar to nonpolar, you go away from having charge, which means that you start to have a balance of positive or negative molecules in your solvent and it becomes more neutrally charged. Olive oil is our most neutrally charged or nonpolar solvent. So we're talking water today, right? So really the number one molecule that exists in plants and fungi that we are going to be looking at today are carbohydrates. Carbohydrates, which can be broken down into sugars and polysaccharides. And so let's take a deeper look at these wonderful molecules. Carbohydrate molecules are really what are most soluble in water, what are most nourishing to the body and the immune system specifically, but not necessarily limited to the immune system at all. The urinary tract, the digestive tract, they can be very moistening, they can be very building, they can be very nourishing, but carbohydrates are starches, carbohydrates are sugars, and so they're food for the body ultimately, and they're water soluble. They have a high dielectric constant or they have a high polarity, the molecule itself. So that's the bigger concept I want you to understand here when we're talking about polarity and solvents. Okay, so what's the big deal? Why are we talking about this? Because the molecules in the plant or the fungus also contain a charge, right? So all of your molecules in the plant are charged, your solvent is charged, and like attracts like. So if the carbohydrates that are contained inside of your plant have a charge, have a positive or a negative charge, they are going to be attracted to those water molecules because like attracts like and it creates a bond. So that's just kind of another way of describing how the solvent is extracting the medicine from the herb. It's attracting the molecular charge of that specific constituent in the herb, okay? Or the fungus. Carbohydrates, breaking them down into polysaccharides. And then there's so many different subsects of polysaccharides. The carbohydrate is kind of just a large category term of all these different sugars and starches. And then a polysaccharide narrows it down further. And then from there, all these different acting molecules are considered polysaccharides. So you've got gums, you've got pectins, and you've got mucilage.